Problem says, although it's a very common problem. Problem says longest common subsequence. Statement itself. Subsequence, I will be given two strings, text1 and text2. And I know the subsequence is, if I, let's say, take this string A, B, C, D, E. So a subsequence is, okay, I can go in the sequence and I can take any characters A, C, E, or maybe A, B, E. So it said, okay, I'm going in the sequence from left to right and then I'm picking any characters. I can jump off, I can hop off. That is a subsequence of a specific string. And I want, okay, I will be given two strings. I want to know what's the biggest or the longest common as in it should be in both of them. The subsequence should be in both the string text1 and text2, and it should be a subsequence, and that should be common. And what is that common maximum length? I have to just return that specific length. So with the example itself, all the examples are not very big. You can see A, C, E, A, C and E. You can see A, B, C. You can see A, B, C. You can see nothing is matching. So answer is U. But yeah, examples are not that great. But firstly, it's one of the problems which have a very much a real life use case. How? So you have seen okay, whenever you submit a wrong answer on Leetcode, there's a diff which is showed to you. How that diff is generated is just because of this specific longest common subsequence algorithm in the best possible time. You see, you want to have a diff. Let's say if you copy in clipboard, if you have used IntelliJ, if you have worked on projects, then you know, okay, that copy to clipboard is an option. It's compared to clipboard. So you can compare the entire files in IntelliJ, and that's also because of this algorithm. Not only this, but also like you say your friend, मैं तेरा बाप हूँ, तू मेरा बाप है, like you say to your friend that मैं तेरा बाप हूँ, so that, okay, then you can just actually get your DNA matched, that he is actually he is your father or not. That's a term between boys, but yeah. And ultimately, Grammarly and other websites, again, Grammarly use a very high complex algorithm because it's very fast and it can work on numerous number of words, but a part of it is actually also comparing two words and finding what's the longest common subsequence between them. Again, Grammarly is a star marked because it actually uses a very complex algorithm. I have seen that it's very complex, and also like DNA matching is also very complex, but yeah, no worries. A sub part of the problem is actually longest common subsequence matching. Now let's see that how we're gonna solve it. I will not even apply my brain. I'll just do as the question says. Find longest common subsequence, which means I will be given two strings. I will find the subsequence for both of them. I will find the subsequence for the string. Like I have two strings. Let's say the string text1 have length n, string text2 have length m. So I'll find the subsequence of text of length n. Okay, all the subsequences, which is nothing but whenever you find a subsequence, let's say I have a text, let's say text1 is ABC, it's of length n. So whenever I have to find a subsequence, I will go on to every character and I will ask him, bro, can I take you, can I not take you? Take it, not take it, take it, not take it, take it, and not take it. So you saw two ways. Ultimately, you have n characters. So it is 2 to the power n number of ways to form the subsequence. Okay, so text1 I have 2 to the power n number of ways. Text2 I have 2 to the power m number of ways. Again, I have to just know and get to see if that specific out of all the 2 to the power n subsequences, out of all these subsequences, I'll just grab one subsequence and we'll check if that subsequence is in my other list or not, which is of 2 to the power m size. If it is, then I have a subsequence matching. Okay, it is matching. I have a common subsequence I have found. Just try to maximize its length. Okay, I will just have a variable and I will try to like answer and I'll try to maximize that answer. Just simple that. So you saw it is nothing but you will generate all these subsequences of length n, all these subsequences of length m, and then you can just compare as in, okay, if that string, you can iterate on all of those 2 to the power m n number of strings and then compare, is it actually in your in this list or not on the right side. And that's something, a simple hash value you can maintain. For that, you will see that the time needed will be 2 to the power n plus 2 to the power m to actually generate all the subsequences. Space doesn't matter at this point because time itself is way too high. Although space will be roughly also same because you have to store in the hash map. But still, it is very high because my n and m are 1000. It will not work at all. So the first obvious thing in an interview, again, for you, you know it's actually a DP, but we'll still prove by intuition that okay, why it is actually a DP. But before that, it's always good to have a quick check that is it a greedy or not? Because it seems like, okay, if I have two strings, why can't I compare character by character? If it will match, then I will go on. It's an obvious thing, but greedies are always harder than DPs. You might say, Aryan, what the hell are you doing? I hate DP. But you don't even know. To prove greedy, it actually takes a lot of effort, because greedy can be done only when it is proved that it can never be wrong or it is right. So either, like, to prove a greedy as wrong, I can either prove that, okay, it is actually wrong, or I can make a use case, or I can give an example, a contrary example, which can actually prove that greedy is wrong. So for me, again, in an interview, it's basic intuition. Okay, I have two strings. Why can't I match character by character? That's as simple as that. But I will see that why greedy will not work. So that is example. Again, this example was hard to build, considering I knew that I have to go on and write multiple examples. Then I got to know, okay, greedy might not work, but I have to bring out the use case. So yeah, building examples for greedy itself is actually hard. So yeah, but yeah, greedy says that, okay, if I match, I'll go on to and say greedily whatsoever character is in the text 1, I will try to match it with the text 2. Okay, I encountered a I will try to find my first A in text 2, and okay, I got a NA. Then I wanted a B. Okay, I know I don't have any B. I wanted a C. I don't have any C. I don't have any D. I wanted an E. Oh yeah, I have an E. Okay, cool. I have an F. I have no F. I have G. I have no G. I have H. Yeah, I have H. So by greedy, you saw the length was 3. But it was just one point of greedy, which means you just contained, okay, you just thought of that I'll just choose greedy from the text 1. What about the text 2? It can also be starting point. So okay, when the text 2 is actually a starting point of greedy, okay, D and D matching, then C, D, nothing is matching. Okay, E is E matching, H and H matching. Okay, again, from greedy, I am getting answer as 3. But now I just thought of, okay, my text 2 I'll keep as a starting point. But is actually true? No, because the optimal answer is that C and C are matching, D and D are matching, E and E are matching, and H and H are matching. This is the longest common subsequence length. So you saw that greedy will not work for sure in this case. Now, ultimately, if greedy will not work, then we are back to square one. We have to use the recursion. Now, if you saw above, then you were generating all the subsequences and then comparing. Now, I'll say, okay, I'll not do that. I'll generate all the subsequences, which means, again, to generate the subsequence, which means from text 1 and text 2, you will simply say take or not take it or ignore it if your pointer is at the, because so it's for sure that you have this text 1, you have this text 2, so your pointer will be at text 1 first and text 2 first. So you will have, okay, for the above one, you will have options, take it or not take it. Above, like the pointer which you have below, you have two options, take it, not take it. So again, but in this, that take it can only work, take it, which means you are taking both the characters from this text 1 and text 2. You can only take them when they are same, right? That is the point of common subsequence. You can only take when the actual, you can see, you only take when the characters were same. You only take when the characters were same. You only take when the characters were same. So, okay, I can only take when the characters are actually matching. If not, then I will have to ignore them. I will simply ignore them. Ooh, let's see how it will look like. So, initially, I have my both the pointers here. Now, for sure, they're not matching. I will have to ignore them. But ignore as in, I can't ignore both of them. That's of no point. That's like, with this, I will keep on moving in my, I cannot do, okay, both are matching, both are not matching, okay, ignore both of them. You remembered, I was generating subsequences for both of them, which means from the text 1 also and text 2 also. So in one case, I can just ignore text 1, and in other case, I'll just ignore text 2. Which means, as you saw initially, both pointers was here. Now I said, both are not matching, so simply ignore. But one time, ignore one. Okay, so you saw that I ignored A and moved my pointer of text 1 forward. Here I ignored the text 2 first pointer and then moved my text 2 pointer forward. Now, okay, this is a new thing. So again, for this, I'll simply again ask, bro, simply, you see B and D are not matching, so simply ignore, but ignore one at a time. So you saw I'll ignore B and move to forward in text 1. I ignored my D and moved forward, which is C. So you saw, okay, I moved forward. And the same way on the right side, which was what I have made already, I again try to ignore it. Okay, I'll ignore my A first. Okay, A is ignored. It moved forward in text 1. I ignored my this C, and I move forward in text 2. So first thing, so far first thing you saw that you have reached to a common sub problem. Again, we have not gone to all the possibilities because we have just ignored it so far. We have not taken it. So yeah, we have not gone to all the possibilities, but so far while building our example itself, we have seen that we have reached a common sub problem, because the problem will start off itself with this specific, that okay, your text 1 is at B, text 2 is at this specific C, and the same was here itself. So you know, okay, you have a common sub problem, which means you have a repeating sub problem for sure. You can apply DP. That is for sure, you have gotten point. And up till so far, which means okay, if you are at let's say I and J, so you also got to know one thing, that okay, you will either move your I, which means here I moved I plus 1 and J remained there, and here I moved my J plus 1 and my I remained there. So I will have two options: either I will solve from I comma J plus 1 or solve for I plus 1 comma J. And again, I want the longest common subsequence, so I will make sure that this returns the length, and that I will take as the maximum. Whatsoever will give me the maximum. But again, this is what we had seen so far when I was ignoring. What if I actually match? Let's see. Now again, it will keep on repeating. Okay, ignore and ignore, and then here you will see C and C. Now they are matching. Now are in what? Now if they're matching, now what? So if they're matching, then take them and then move forward. Okay, I'll take them. Now if I take them, which means C and C I have taken, for sure one thing, remember one thing, if I have taken C and C, which means I have found one length subsequence which is matching. Okay, add a 1, because you have found a C and C, it will form a one length subsequence which is matching, and then solve for I plus 1, which is this I plus 1, and this is J plus 1. And again, let's say if this also match, so you can see, and this is also matching, so you will also take this, and you will again for this matching also you will add a plus 1, so now it will actually become a 2. Your length will become a 2, because you can see CD is actually a subsequence length which is actually common in both of the strings. And then again you can simply move on your I plus 1 and J plus 1, and that's how you can simply solve it. These are two cases. If it is matching, do a 1, which is the length, you will simply add 1 in the length because you have found one character. And if it is not matching, simply try for I comma J plus 1 or I plus 1 comma J, take the maximum out of it. If you code it, it's pretty simple. That firstly, I wanted my all the variables as global, so my DP and text 1 and text 2 I wanted as global, because I just don't want to pass in the argument. I wanted to have it a clean implementation, so I made these as the global variables. Again, you can also pass in as the argument, that I'm not concerned about. So I just initialize my N and M so as to use it in my DP initialization, and then I use my text. It is just okay to make it as a global variable. Now here you will see that I initialized my DP of size N and M by default with the value of -1. It is how usually standard memoization work, that you initialize with the value of negative like -1, and then I'll solve it saying initially I'm starting from I and J as both 0 0. As you saw in the very beginning, you were starting from very 0 0. Now the code is pretty simple. I have a simple base case. If any of my I or J reaches the super end, simply return a 0. If any of your exceeds, then simply return 0. It's of no point. You cannot even go forward if your I and J exceeds, because it's the indexes, right? And the base, and the memo case, simple. If that DP of ij is not equal to -1, which is the default value, which means you would have put in this value. So simply return that value already, so as to memoize and not go again and again in the loop. And now comes the actual case, that if my text is matching, my text 1 of I and text 2 of J is actually matching, then simply add 1 in the answer and solve for I plus 1 comma J plus 1. If it is not matching, then solve for I comma J plus 1 and I plus 1 comma J. And that's how you can simply, in these 4 lines, you can simply solve your entire problem. You will see the time complexity is actually nothing but O of n into m, where n is the size of the text 1, m is the size of text 2, and your DP space is also O of n into m, and this entire recursion, because of memoization, will also go into n into m time. So you saw that is O of n into m for both time and space. Now interviewer will ask you, can you optimize it? But I have already told 100 times you can do optimization in top down DP only when you convert that to bottom up. So I'll use the exact same code. This was the code of top down DP which we saw above. I will use this code to figure out. I will not build, I'll not write from scratch. That's the whole point. I'll not write from scratch. I'll use this top down code to actually write the bottom up code. So I know, okay, if I was at ij, I wanted to access my I plus 1 comma j plus 1. I wanted to access my I comma j plus 1, and I wanted to access my I plus 1 comma j. So rather build from that itself. So if I am saying, okay, this is the I, because see, bottom of DP is a simple table matrix, right? So I know, okay, I and j is at this. I just plotted. I just made an open matrix. I just made an open matrix, and I know, okay, I am at index I and index j. I want to find this value. Then I went on to my top-down code and I asked him, bro, can you please tell me how I can help? So he asked me, okay, bro, you need I plus 1 comma j plus 1. So I need this specific value. So I made another column. Okay, I need this specific value. Then he will say, bro, you also need I comma j plus 1, and you also need I plus 1 comma j. So I asked him, okay, I comma j plus 1 is this value, and I plus 1 comma j is this value. So I realized that if my characters are same, which means text 1 of I is actually A and text 2 of J is also A, which means if ith and jth character of text 1 and text 2 respectively are same, then I know that I will simply, okay, to find this DP of I comma j value, I'll simply add a 1 in DP of I plus 1 comma j plus 1 value. So one thing we have got to know so far, okay, I can simply compute that, but it's also obvious that I should be knowing this DP of I plus 1 comma j plus 1 value also. So it also internally means that I will be calculating my answer like this from the bottom. So whenever I have reached here, I should be knowing the answer for the bottom part. Again, you can also, if I just erase this, you can also compute the answer. Like you can also, you can also compute the answer. You can also compute the answer like this also, that let's say you are at here, so you can compute the answer like this also, right? So that, like, it's just to make sure that, okay, you have your previous portion ready. Now again, let's say here we saw if it was matching, then I will just take the help of DP of I plus 1 comma j plus 1. What if it is not matching? No worries at all. Then simply take DP of I comma j plus 1 and DP of I plus 1 comma j to compute the DP of I comma j value. DP of I comma j is nothing but maximum of these values. I took nothing but I used this exact same code to figure out where in table and how in table I have to compute this. So we have got to know this relation. We have also got to know to actually obtain or need this value, I will have to go on from bottom, which means I will have to iterate in like this, or I will have to iterate in like this. Anyway will work for you, right? So you will see that I simply iterated. I firstly, exact same thing, it's just that I initialized with n plus 1 and m plus 1. Aryan, why you did that? I did that because in the very beginning, when you will be computing this value, here it is I and j, which is this specific last index. It will try to access this specific value. So either you can handle that as an edge case, or you can just initialize this entire thing as a 0. So it will try to access it and it will simply return a 0 itself. That is the reason I just had a bigger value. Although you don't need it, you just can handle that in your edge case also, that for the borders initialize with the respective values. If it is matching, then 1, if it's not, then 0, like this. But yeah, we are very clean code people, so we just simply handle it here itself. Now I'll simply go on like this. Again, as I told you, you can also go in, like for example, for int I equals to n minus 1. Now my I is nothing but representing my rows, and j is nothing but my columns. I equal to 0, I minus, and for int j equal to m minus 1, j is equal to 0, and j minus. You can also write the exact same thing like this. I just mentioned that either you can go on like a row from the bottom or the column from the bottom. In this, I am going in from the column because you can see I'm going in from the j, but for example, for this specific j, I'll go on to all of these columns, but in the bottom code, which I'll show you, I'll also go in the row wise. But again, both are same and you can use both of them. Exactly same. Cool. Now, so if I just go on, and that is nothing much for concern for us. If I go on, the simple use case is if the texts are matching, then simply take in I comma j as 1 plus I plus 1 comma j plus 1. If they are not, then simply take the I comma j plus 1 and I plus 1 comma j. Exact same code as we wrote for top down. Now, if we have written the exact same code, for sure the complexity is also exactly same, which is m into n, and space is O of m into n. But what's the point of writing this code? The point is that maybe we can visualize if we can optimize it or not. And here we got to know that yes, we can. How? Because if we go and see that to compute this specific value of I comma j, we only need these three values. So if I want to compute this specific row, I need these values. So to compute this specific row, I need only the previous row and for sure this row itself. This is, I figured out that to compute this specific row, I need only the previous row and also this row itself. Because why this row itself? Because to compute this specific column value, I need the previous column also. So this is how I got to know so far that okay, I was wasting my entire space storing all these elements, which is not required at all. So what I'll do is, oh good, that I don't need all these space, because okay, if I have n rows, I only need 2 rows. That's it. That's the maximum number of rows I need. I only need 2 rows. I don't need n rows. So my space will actually be reduced by n. I don't need n rows. So I can actually say, okay, I need only 2 rows of size m, because you know I have m columns. So I know I can take 2 rows, only 2 rows of size m, and that's how I can simply get the answer solved. Again, the code will be pretty simple. I'll take the exact same bottom-up code. In that code, I know, okay, I will not need a 2D array. I will just replace my current row operation with my DP and my bottom row operation with my previous DP. So whatsoever you are seeing above, the current row I will replace by DP and the bottom row I will replace by previous DP. So again, when we say replace, so we will not need the row column. So I'll replace my DP of I comma j with nothing but DP of j only. This DP of I plus 1. Now I plus 1 saying the bottom row. So I'll replace that by previous DP of j plus 1. You can see your previous DP of j plus 1. Same way, your DP of I comma j is nothing but the current row. So you will replace that by DP of j. Replace that by your DP of j. And the same way, your DP of I plus 1 is the bottom row, which is the previous DP now. So you will replace that by previous DP of j, and this is the DP of I comma j plus 1, which is the current row but previous cell. So you will just replace that by the DP of j plus 1, and that's how, with the simple modification, you can actually solve it. So if I write it down, and again here for the example, I replace my ing so as to show you that okay, I can go on from the bottom also. So here you will see that I just simply replace it what I showed you above. Exactly same. And this with this, and again I removed the 2D vector and I initialized 2 linear vectors, which is the previous DP and my simple DP. That's it. Now with this you might say, Aryan, that is super great. With this your space complexity will be O of 2 into m. That's true, and you can roughly say it's O of m. But what if your entire table is screwed, which means you have just 3 rows. Let's say you have just 3 rows in your table, like your text one has n length is 3 and your m length is, let's say, 1000. So still, like, your answer of O of m is actually more. Can't you do a O of n? So yeah, for that I have a trick. What I'll do is I'll take minimum of any of them, O of m or O of n. So right now my space will be taken as O of m, right? But I'll now say, okay, I just wanted 2 rows, either 2 rows or 2 columns, so as a value. So rather I can just simply replace it, which means right now if my n is 3, m is 1000, what I'll do is, okay, I'll simply replace them. I'll simply swap them. Now my n will become 1000 and my m will become a 3, which means if my n string was the ABC, now ABC I will put it as a string 2, which means text 2, and my string 2, which was, let's say, A B C D E F G H, that I will put it as a text 1. So now my m will become a 3. So with this, the space will be nothing but O of m, which is actually very small. So now I just say that my time complexity will be nothing but minimum of n and m. What I mean by that is that if my text 2 size is more than the text 1, then I'll simply swap my text 1 and text 2. So my text 2 size will always be less in any case whatsoever, and thus my answer will always be minimum of n and m, which means the smallest possible size of both the strings. Whosoever has the smallest possible size, take that specific string, and that will be your answer. With that, you will always take the minimum space possible, and this is the most optimized code which you can actually tell in an interview. And again, this is something which the interviewer can expect you to go from the very brute force, which means recursion, which means firstly brute force, which means simple recursion, which is a simple having all these subsequences, then figuring out, okay, greedy will not work, then going on to top down, then from that going on to bottom up, and then going on to bottom optimized. It is actually expected because it's a very common problem and you should be able to tell everything in an interview. Okay, cool. Thank you very much. Goodbye. Take care. Bye bye.